the problems that we've seen with related rates kind of give rise to a certain strategy just for how you're really supposed to, when faced with one of these problems, how are you supposed to deal with it? Well, of course, the usual thing is always to first read the problem carefully. Because a lot of the times with these, you have to figure out what you know and what you're being asked to do. So the same as any kind of problem, any kind of word problem. And what's very useful for these, always you're going to end up drawing a diagram, almost always, but pretty much always, because there's some geometric thing involved, right? There's some geometric relationship between the different variables that's given in the problem. So you sort of have to figure it out. So whether it's like cars driving one way or the other, the ladder sliding down the wall, you've got a conical tank that is, dripping water, whatever it is, there's some geometric thing. So draw the geometric thing. Once you've drawn it, then you can assign variables. Okay, so, and the important thing is some quantities don't change through the problem, as we saw in the problems that we've done already. Like the ladder, the size of the ladder is always 13 feet. But the rest of the quantities in the problem do change. So if a quantity is changing, give it a name. Okay, so that's important. So that's sort of assign variables, introduce notation. You want to think about assigning those variables to everything that changes with respect to time. So assign variables to everything that's changing with respect to time. And then for the constant quantities, you can just put them on your chart. So label constant quantities, because that is helpful when it comes on your diagram. That is helpful when it comes to this next step. The next step is that you want to figure out the relationship between the variables, right? So you want some equation, right? So write down an equation that relates the variables. And okay, you don't have to do these in this order. You can do the 3, 4. The other thing I do like to do is write down the rates. I think you saw me do that. Label EL, thank you, the rates of change. Just because it helps keep everything straight. So on your diagram, you'll just have your variables, but the problem will often be asking about the rates of change of those variables. So it's useful to write down, like in a little thing on the side, what rate of change corresponds to which thing, so that you know what you're eventually going to plug in. Once you have all that set straight, you can then take the derivative with respect to time. So take d dt of both sides of your equation. And then number 7, I'm out of space, move it up here. Number 7, solve for the quantity you want. So this is the part, both of these, so this is where it kind of can get tricky to keep it straight. right? So you've written down an equation, it relates the variables, you've figured out what rates they've given you, and typically they're asking you for some rate. So what rate do you need? And then once you take the derivative, you have a relationship that has those rates in, and now you have to substitute back in to get the quantity you want. Sometimes, though, you also have to figure out other information, like we did with the ladder problem, right? Because they didn't give you the y that corresponded to x equals 12, so we had to go back to the original problem and figure that out. So sometimes that sort of thing happens too. So this might be a little bit more complicated just because you might have to go back to the original equation to figure out certain parameters. But that's the general strategy.